In this video, we will learn how to derive the consumer's surplus formula, and we will also solve a numerical question. Okay. So let us say we are being given this inverse demand function, that is price is a function of quantity. Okay. When sketched on this graph, it shows us different prices that the consumers are prepared to pay for the various quantities of a good. By this, what we mean, if we have, you know, if price is 4, let us say quantity demanded is 6, and when price is 3, let us say quantity demanded is 8. Okay, since this is the inverse demand function, by law of demand, when price decreases, quantity demanded increases. Okay, so on the graph, this demand curve gives us the different combinations or different prices that the consumers are prepared to pay for the various quantities of good. Okay, now let us suppose, in this case, let us say initially we have a price of P naught. Okay, corresponding to this price of P naught, let us say quantity demanded is Q naught. Okay, so when price is P naught, quantity demanded is Q naught. Now, what is the total amount of money spent? So total expenditure, and let's write it here, total expenditure or total amount spent on the good is equal to P naught times Q naught, that is the price paid times the quantity demanded. This shows us the total expenditure. And on this graph, and let me be very specific, let us say this is point O, this is point A, this is point B, and let us say this is point C. That means the total expenditure is actually the area of this rectangle O, A, B, C. Okay. Now, P naught is the price that consumers are prepared to pay for the last unit they buy, okay, which is the Q naught good here, okay. Now, for quantities up to Q naught, up to this Q naught, they would actually be willing to pay the higher price given by the demand curve. Obviously, there will be some consumers who would have been willing to pay higher price given this inverse demand function. Okay, since they are, since they are paying a fixed price of P naught, the area above this demand curve. Okay, so there will be different, different prices that they would have been actually willing to pay for. Since they are only paying the price P naught, then and let us say this is A, B, C. Let us say this point denotes D. Okay, for quantities up to Q naught, they would actually be willing to pay the higher price given by this demand curve. Now the area, this area ABD, this represents the benefit to the consumers of paying a fixed price P naught. Okay, so this triangle will definitely be the benefit to the consumers because they are only paying a price, P naught, and there would have been other consumers, they would have been actually paying a price of, let us say, the price above the P naught. Since they are only paying a price of P naught, that means this area, this triangular region denotes the benefit to the consumers of paying a fixed price, that is P naught, and this triangle actually is the consumer surplus. Okay, so consumer surplus is actually this triangle, the area of triangle ABD. Okay, now how do we calculate this area ABD? So for this, what we need to do, and let us say here, that is area of rectangle ABD will be equal to, that will be equal to the area of this whole region, okay, of this trapezium. We are assuming here this is the linear demand function. Okay, so it will be equal to area of the region OCBD minus the area of this very rectangle, that is OABC. Okay, let me explain it again. The area of this rectangle, sorry, this triangle will be equal to the area of this whole region, and when we subtract this rectangle, we are left with this triangle. And graphically, if I want to show it here, so let us say we want to find out the area of this rectangle. the area of this rectangle will be equal to the area of whole region. Let me show it like this. The area of this whole region, and from this when we subtract the rectangle, this rectangle, okay, we will be left with this triangle. So the area of this whole region, that is OCBD, the area of this region is the area under the demand curve here. Okay, so the area OCBD is actually the area under the demand curve, which is P is equal to F of Q. Okay, now that implies the area of this whole region, or the area of this triangle will be equal to, and let me write it here. Since this triangle denotes the consumer surplus, so consumer surplus will be equal to the area of this whole region. So how do we find out the area of this whole region? Simply we take the definite integral from 0 to the equilibrium quantity demanded, that is Q naught. Okay, and we integrate this demand function f of Q dq. Okay, so this will give us the area of this whole region. From this, when we subtract the area of this rectangle, that is, what is the area of this rectangle? Since base is Q naught and height is P naught, that means area of this region will be equal to Q naught times P naught. This actually shows us the, and what is the consumer surplus here? Consumer surplus, and let me show it here properly. Consumer surplus is here area of triangle ABD, that is our consumer surplus here. Okay, and what does this definite integral from 0 to Q naught denote? It denotes the area of whole region, that is OCBD. So this is area of OCBD. Okay, so this denotes this, minus this Q naught P naught denotes the area of this triangle rectangle, that is area of rectangle OCBA. Okay, and this gives us the formula for calculating the consumer surplus. Consumer surplus is simply the difference between the price that the consumers are willing to pay and the price that they actually pay. Okay, now let's take a numerical example here. Let us say we have a demand function, and let me write it here. Let us say we have a demand function P is equal to let us say 30 minus 4Q. Okay, given this demand function, if we are being told to find consumer surplus when quantity demanded, let us say quantity demanded is equal to 5. Okay, given the demand function, and if we are being told to find out the consumer surplus when quantity demanded is 5, how do we find out that very step? Very simple. Let's first try to draw the graph here. That will make sense here. We have quantity demanded on the horizontal axis, price on the vertical axis. We have at negative sloping demand curve. Okay, so here it is 4Q, sorry. So let us draw this demand curve here, and it is price intercept is here 30. Now the consumer surplus, to find out the consumer surplus, we will be using this very formula, and let's write it here. So consumer surplus will be equal to, so given this demand function, first what we need to do, we need to find out the initial price and initial quantity, that is equilibrium price and quantity. So given P is equal to 30 minus 4Q, since Q naught will be equal to Q here, okay, which is equal to 5, then what will be our price? To find out the price, we simply plug Q is equal to 5 into this demand function, that is 30 minus 4 times 5. So this is price will be equal to 30 minus this is 4 5s are 20, we will get 10. Okay, and let us say this is our P naught. Okay, then what is the consumer surplus? So we have P naught is equal to 10, Q naught which is equal to Q here 5. You can write P and Q, but I'm just trying to relate it with this example, this derivation. Then consumer surplus will be equal to, so when P naught is 10, so when price is 10, what is the quantity demanded? That is 5 here. Okay, and let us write it here. We have this denotes the P naught, this denotes the Q naught. Then consumer surplus will be equal to, consumer surplus will be equal to, we need to find out the area of this very triangle here. So consumer surplus will be equal to the definite integral from 0 to equilibrium quantity, that is Q naught. Okay, here then f of Q dq, the area bounded by this curve up to Q naught. To this we subtract the total expenditure. And what is the total expenditure? That is P naught times Q naught. Okay, P naught times Q naught denotes the total expenditure. And here it will be equal to, so we have to take the definite integral from 0 to quantity demanded, which is 5, and we integrate this demand function, that is 30 minus 4Q, and we integrate it with respect to Q. So from this we subtract the total expenditure, that is P naught times Q naught, that is 10 into 5. Okay, let us write it here now. So consumer surplus will be equal to, when we take the definite integral, so the integral of 30 will be equal to 30Q minus the definite integral of, the integral of Q will be equal to Q square upon 2. Okay, and we evaluate it from 0 to 5, and we subtract the total expenditure, which is 50. Now if we evaluate this these variables at upper limit, so what will we get? We will get 30 into, in place of Q we have 5, minus, here 2 ones are 2 2s are 4, we are left with 2 times Q square means 5 square, 5 square. Okay, then we subtract and evaluate it at lower limit. Since lower limit, when we put Q is equal to 0, so this will become 0. 30 into 0, here it is 0 square, so whole stuff will become 0, so we will not evaluate it at lower limit, it will come out to be 0. From this then we subtract this 50. Okay, solving this we will get, this is 3 5s are 15, so we get 150 minus 5 square go 25 into 2 go panza. To this we subtract again this 50. That means our consumer surplus will come out to be 150 minus 100, which comes out to be 50. Okay, that means the area of this very region comes out to be 50. Okay, there is another way to solve this kind of question. Since we are being given a linear demand function, we can simply find out the area of this very rather the area of this very region. Okay, so when we have the linear demand function, it will be more plausible to simply use the area of a triangle formula. That is, area of triangle is equal to 1/2 of base into height. And here you can see we have 1/2 of, what is base? 0 to 5. So here let us say the length of this is 5 times the height is 30 minus 10, which is 20. Here you can see we will also get same stuff result. 2 ones are 2 10s are 20, so 10 5s are 50. Okay, so you can simply find out the area of this triangle by using the area of a triangle formula. Okay, since this denotes the consumer surplus. Why I am doing this stuff? Only to make sure that if we have a non-linear demand function, then we have to use this integration per stuff here. I hope I make myself clear in this video. Thank you.